Welcome students. Today we are going to talk about one of the most charming, elegant and surprisingly the simple concept in probability theory, the Markov processes. If life had the Markov property, we would never worry about our past mistake. Sadly, only math behaves so well. A Markov process is basically a sequence of random events where the future depends only on the present state, not on how you arrived there. This magic is called the Markov property, memoryless behavior. If you are late every day, your teacher does not care about your past excuses. They only care about today's excuse. That's Markovian concept. Now, the core tool of a Markov process is the transition probability matrix. Each entry tells us if you were in state I now, what's the probability you jump to the state J next. If the rows of the matrix behaved like students in the class, perfectly summing to one and never misbehaving, life would be beautiful. We studied two main types. Number one is the discrete time Markov chains, that is DTMC. The time moves in the fixed steps, like for example, the weather models like sunny, cloudy. And in the next day's weather cares about only today's weather, not about your embarrassing childhood memories. Number two is continuous time Markov chains, that is CTMC. Here the jumps happen at random times governed by the exponential distributions. Think of it like your mood swings, unpredictable but statistically predictable. The process is defined by the transition rates, not probabilities. But why do we love Markov models so much? Because they are used everywhere. Queuing the theory, stock price models, Google search rankings, DNA sequence analysis, customer behavior patterns. The world is basically a giant Markov playground. Now, the special tips for students. Always visualize the states using the diagrams. A neat state transition diagram can save you from the 20 minutes of confusion. Number two, memorize the common matrix operation, in-step transition, stationary distribution and eigenvector models. Once you get this, Markov chains feel like a friendly pet. Number three, solve the small examples by hand. It builds your intuition. Number four, remember that long run behavior matters. Stationary distributions explain where your system settles after many steps, like where students settle after lunch break, usually in the canteen. So, let's make the probability feel natural, not scary. Join Dr. Shorob's classes today and make all your dreams come true with us.